we're getting into some ever more complicated Hess's law problems. Some of the legendary ones on the diploma exams get up to like 5 or 6 reactions, but you can do a lot with just 3 or 4. So, as usual, we have this set of reactions that are given to us, and we are asked to make this thing. It has some coefficients in it, so I take it is balanced, but do keep an eye on that. They can throw you an unbalanced one and expect you to catch it. So, we need N2H4, 1 mole of it on the left side, and reaction 1 is lovely. It gives us exactly that. So we're going to take reaction 1 as is, which gives us N2H4 and 3 oxygens. That makes 2 NO2s. And notice in this one, unusually, we have water in liquid state, and in other places we have it in gas state. Those are not the same thing. You have to treat water and steam like they're separate entities, and so we're going to have to be diligent in this one, as I often am not, about tracking physical states. Writing that like iron is a solid every time, I often leave out because I just don't think it's useful and it's kind of a distraction. But we're going to have to be good about our water here because it costs a lot of energy to convert liquid water to steam or back again, and this is the unit where we keep track of energy, so we have to be good that way. Okay, so N2H4, I think we have that done. Now we need 2 hydrogen peroxide, and we need that on the left side. How do we get, oh, here we go. Reaction 2 provides peroxide, but it's 1 mole and it's on the right side, so we have to flip this reaction to get H2O2 to the left, and we also have to double it. So I'm going to put -2 times reaction 2. This flips to the left and becomes 2H2O2. Arrow. This flips to the right and becomes 2H2O liquid. Remember, we're being careful with water because we have both forms of it. This flips to the right and becomes 1 oxygen because it got doubled, and that should do us for the H2O2. Now we need 2 nitrogen on the right side, and reaction 3 is the only one that contains nitrogen. Sadly, this gives half a mole of it, and it's on the left, so again we have to flip and double. -2 times reaction 3. So if we do that, NO2 flips to the left and we double it. 2NO2, arrow. The half nitrogen flips to the right and gets doubled, so now we just have 1 nitrogen. The oxygen flips to the right and gets doubled, so now we have 2 O2s. Okay, that does it for our nitrogen. And finally, this reaction is supposed to produce 4 moles of steam. And of all the reactions here that talk about H2O, only reaction 4 talks about steam. And it does have it on the right side, but it's only 1 mole of it. So to get the amount we want, we have to quadruple reaction 4. 4 times reaction 4. So, on the left we get 4H2O liquid, arrow. On the right we get 4H2O gas. And now, if we hack away all of our spectators, what do we end up with? N2H4 doesn't cancel. On the left we have 3 O2s, and on the right we have an O2 here and 2 more here. So we can cancel all those. That's equal amounts of oxygen. We have 2 NO2s on each side. We can lose that NO2 and this NO2. And for liquid water, we have 4 liquid waters on the left. Here are 2 on the right, and here are 2 more on the right. So we can cancel 4 off the left side, 4 off the right side. And does that leave us with what we wanted? N2H4, check. 2H2O2, check. 1 nitrogen, check. And 4 steam, check. Okay, so all of these reactions came out right. We've built the thing we wanted. And the big finish, what is the enthalpy change? We took reaction 1 unchanged, which means we take its delta H unchanged, minus 466.0. We flipped and doubled reaction 2, which means we flip and double 98, which gives us minus 196.0 if you like. We flipped and doubled reaction 3, so we flip and double its delta H. We get negative 68 for that. And we multiplied reaction 4 by 4, so we multiply this by 4, which is 163.2 when it's positive. And so out come the calculators, and we get a total for that. Negative 466 minus 196 minus 68 plus 163.2. If I keyed everything right, we get minus 566.8 kilojoules. Not too bad, right?